Okay, this is lesson 36, classifying triangles. So there are two different ways to classify triangles, and that's what makes it a little confusing. You can classify a triangle by the size of the angles or by the length of the sides. So by angles, remember acute is a cute little angle, less than 90 degrees, less than a square corner. So you could have a triangle that is an acute triangle. So in that case, all three of those angles are less than 90 degrees. They're all small little angles. A right triangle has one angle that's 90 degrees, or one square corner. And an obtuse triangle, one angle is obtuse. The other two can be acute, but if one of them's obtuse, or big fat wide, then that is an obtuse triangle. If you classify them by sides, you can have an equilateral triangle, which all sides are the same equal length. You can have an isosceles triangle, where two sides are the same length, and a scalene triangle, where nothing matches. No sides are the same. Okay, so example one, actually let's leave that here so we can take a look at it. Gives you a triangle, and it says that all three sides of this triangle are congruent. So remember, congruent means the same size and same shape. So they're telling me that each of those sides are an equal length. Okay, so we know that. Which doesn't describe this triangle. Okay, so equilateral, let's go back over here. Equilateral, all sides are the same length. Well, they just told us that, so that one works. Acute, so all three angles are acute. Less than 90, less than 90, less than 90, so that one works. Isosceles, at least two sides are the same. Oh, so are three sides the same? So that tells me two sides are the same, right? What about a right triangle? Now that's one that says one angle is 90 degrees. Well, I just decided that all of those are less than 90 degrees. So that one doesn't work. It is not a right triangle. But isn't it weird that it can be an equilateral and acute and isosceles all at the same time? That's kind of crazy, huh? Okay, so you can classify one triangle several different ways, and that's why classifying triangles is confusing. So take yourself some notes and keep them with you if this is confusing. Example 2, they said draw some angles and make sure that all the lengths of the sides are the same length. So I started off here, and now I'm going to draw an acute angle, so less than 90 degrees. Got myself a little marker, so this is my little ruler. Okay, so there's a cute little angle. Now I'm going to go 90 degrees. I'm going to line it up with the line on my paper so I can make sure it's really 90 degrees. Okay, and now I'm going to do an obtuse angle, so more than 90 degrees. Keep it all lined up. Okay, so I have an acute angle, a right angle, a 90-degree angle, and an obtuse angle. Okay, then it says draw segments to form three triangles. So I can take those angles, and is this going to be the same length? Not necessarily. So now I've made a triangle. Okay. Now I've made a triangle. Okay. Ooh, that one's going to be close. Now I've made a triangle. Okay, so I have three triangles now out of my three angles. So what do I know about this triangle right here? How can I classify it? Let's look at angles first. Are all the angles less than 90 degrees? That one's pretty close, but let's check it out. So if I do that, oh, yep, it's less than 90 degrees because that would be 90 degrees right there, so it's less. So that one's an acute. What about if I classify it by sides? I know those two are the same size, aren't they? So it's isosceles. I can't spell that one. Okay. So this was an acute isosceles triangle. Let's look about this one. Let's do it by angles first. I have one right angle, and I measured that, so I know it is. So that's a right. And I know those two sides are the same. That one was longer when I drew it, so it's also an isosceles triangle. And what about this one? I know those two are, oh, let's do angles first. Okay, there's a big, more than 90-degree angle. So that one's obtuse. And what about by sides? Those two are the same, but that one's not. So it's an isosceles angle. So I have calculated all of those. One of an interesting question that they asked on page 223, they said, can a triangle have parallel sides? No, because they all have to join up, right? So that can't be. And then another thing they ask, out of this, which triangle has perpendicular sides? Ah, that one right there. Right? Okay, so you can classify triangles two ways. Makes it confusing. Good luck.